Okay, now we're on the back of the notes here, and we're going to talk about a couple of properties. One is called the reflexive property, one is called the transitive property. Well, reflexive, if you think of looking at yourself in the mirror, you look at a reflection, what you see is the same thing. So, for example, let's say we have a figure here we're going to draw, and we'll call this here A. I'll say this is C, I'll say this is B, I'll say this is D, right here. Okay, and what I'm going to do is I'm going to draw segment AB. Now, here's the thing. This creates two different triangles. You have the triangle on the left, you have the triangle on the right. Notice that in the middle here, both triangles have the same side. They both have AB. So if I say here's my red triangle right here, and then I say here's my blue triangle right here, and if I trace these, notice that I trace AB twice because both triangles have it. Well, what I can say is that AB is congruent to BA because it's the same segment, and that's what we call the common side, and this is called the reflexive property. This is the reason I can say that AB is congruent to BA is called reflexive. Okay, so again, this is what we call a common side. That's a common side. Now, the transitive property would say something like this. Let's say we have a segment, we'll call it AB, and let's say that we know that that's congruent to a segment, we'll call it CD, and let's say that's congruent to another segment, we'll call it EF. So what we got here, if segment AB is congruent to segment CD, and segment CD is congruent to segment EF, then what does that tell you about these two? Wouldn't they have to be the same? If the first is congruent to the second is congruent to the third, then the first is congruent to the third. Now we've actually seen this before. We did this with logic. We did this with the chain rule, the law of syllogism. P implies Q, and Q implies R, therefore P implies R. The first thing implies the third thing. Okay, so what we can say here, if AB is congruent to CD, and segment CD is congruent to segment EF, then the first segment AB has to be congruent to the last segment EF, and that is called transitive. Now that's reflexive, transitive, that's for segments. Okay, how about for angles? Well, let's say we have something like this. Okay, we'll draw a picture here. Now we've got two triangles. Okay, I'm going to just call this angle A at the top. Let me trace this out here. I'll say here's the red triangle. And then the blue triangle is here. Now this time the triangles don't share a common side, but notice that both of them have angle A right here. If I trace it again, look at what happens with the red triangle. Okay, there's angle A. That's this angle here. And then when I trace the blue triangle, notice that I've got the same angle A. That would be the reflexive property for congruent angles. Now the transitive also works not just for segments, but also for angle measure. If angle A is congruent to angle B, and angle B is congruent to angle C, then the first one, angle A, has to be congruent to the last one, angle C. That is called transitive property. So the chain rule is the same thing as the transitive property. Alright, so the last thing here, let's do one more example. Write 6 congruent statements if the two triangles are congruent. One thing that's crucial to this, you have to recognize symbols. And as we look at this triangle, they've got the two long marks here. That means congruent. They also have these arrows. The arrows mean parallel. Okay, so the long marks mean congruent, the arrows mean parallel. So how are you going to match this up? They tell us that the two triangles are congruent. Now first of all, with angle measure, anytime two lines cross, they create vertical angles. Those have to be congruent. That's always true. Now the parallel lines also give us information. One thing you should always look for with parallel lines, do you see the letter Z right there? The Z is for alternate interior angles. Alternate interior angles. When the lines are parallel, alternate interior angles are always congruent. So those two angles are congruent, they match up. Now do you notice there's another Z? There's a backward Z right here. Those have to be congruent for the same reason, by the same reason, because the alternate interior angles are congruent when the lines are parallel. Alright, so write 6 congruent statements. So let's match this up. For the angles, we can say angle, I'm not going to say M, I could say GMF. Angle GMF is congruent to angle WMK. So I did 3 arcs, 1 arc, 2 arcs. GMF, 3, 1, 2, angle WMK. Now we could say angle F, and you only need the F. That's the vertex, that's the only angle F in this picture, is congruent to angle K. Angle F is congruent to angle K. And then the third thing, angle G is congruent to angle W. Okay, now that's 3. Those are the angles. So how about sides? Well, we've got the top side, GF, corresponds to the bottom side, WK. If you said KW, that's also fine. Segment GF is congruent to segment WK. We've got, alright, now let's see, MF, that's between 1 arc and 2 arcs. That's the side between those two angles. So let me look over here, let me match it up. Corresponding 1 arc and 2 arcs, here's the side between them. So I'm going to put 2 marks on those. FM, we'll say segment FM is congruent to segment KM. And the last one we can say is GM, I'll put 3 marks on that, is congruent to WM. Segment GM is congruent to WM. Now technically I'm done, but the last thing that I'll say, let's also write down the triangle congruence. We could say triangle GFM. And when you write this, you can start it. It doesn't matter which letter I start with. If I start with F, it's fine. If I start with M, it's fine. I started with G, so now if I start with G, I have to match the G to the W. I have to match the F to the K, and then I have to match this M to this M. So it doesn't matter how I write the first statement, but that determines how I write the second. That's it for the notes. So I guess I'll CPCTC you later.